Hello. Hi, everyone. I'm Naveen. I'm the head of engineering at Opsverse. And first of all, good morning, good afternoon, good evening. Thank you, everyone, for joining this webinar where we'll be talking about MCP and DevOps. I have with me my teammate and engineer, Ninash Shelke, who's also going to be joining us today. And yeah, the whole point of us is going to be engineers talking about engineering stuff, trying to do a deep dive into MCP, understanding how MCP plays well with DevOps workflows. We also have a few announcements with Eden going forward, and we'll just try to understand what the hype is and try to break down as much as we can. Right. So without much further ado, we can actually get started. All right. So over the next 45 minutes or so, this is what our broad plan is. We'll be talking about MCP. Obviously, we'll kind of try to understand what is hype, what is reality, why is there so much buzz about MCP in general, right? I'm sure like everyone who's on this webinar today has heard so much about MCP. That's why you're trying to understand: is it really hype or is it really something substantial? Right? So we'll talk about that. Then obviously we'll talk about how we can use MCP. We'll spend a core part of this webinar trying to dig a little bit deeper into like DevOps workflows with MCP. And post that, we have a few announcements about Eden, which are DevOps Copilot that we'll have. And then finally, we'll wrap up. We'll talk a little bit about the challenges that we have with MCP and then what's next in general, right? And then obviously, we do have a Q&A session as well at the end. So we'll keep some time aside for Q&A. In case anyone has any questions, please do post them out. If you're on LinkedIn, you can send them directly on LinkedIn on the live itself, or you can like send them out to us, and we'd be happy to like answer them for you. Right? We're collecting these questions, and we have Tara on the back end who's going to be like collecting those questions and having us answer them at the end of the session. Right. So let's get started. And to start off, I think I'll just start off with this one line, which is kind of what we started thinking about as we started seeing Gen AI starting to pick up more and more, right? And also, as intrinsically, we do believe that the future of DevOps is not Gen AI replacing engineers, but like engineers and Gen AI agents working in tandem, right? And that has kind of been the core philosophy behind us when we have started building Aiden, which is the world's first DevOps Copilot. It's a GenAI powered assistant that's designed for modern engineering teams. And the way that we usually describe it to people is think of Aiden as just another teammate within your organization, right? And just the way that you have a new teammate join your org, on the first day, you probably point him or her towards your GitHub, right? And say, like, oh, this is where we maintain our DevOps code. On the second day or third day, you kind of give them access to AWS, right? On like as the week goes on, you probably want to give them access to Confluence. And then, oh, this is where Grafana is, or this is where Prometheus is, this is where our Datadog is, our New Relic is. All these kind of tools that kind of make part and parcel of your day, right? But in Aiden, what we're trying to do is the same kind of workflow, except have it completely done in a conversational manner, which means that you kind of ask Aiden questions in natural language, and it becomes like the single pane of glass that engineers, your DevOps engineers and SREs need to talk to, and Aiden figures out everything on the background, right? Figuring out which tools to talk to, getting data as is required, doing the data munging, coming up with hypotheses, kind of doing all the things that SREs and DevOps engineers spend most of their day doing. And then obviously that means that Aiden needs to understand how to integrate with all these systems, right? And as with most other organizations that have kind of started building in the agentic AI space, our core assumption remains that every tool that we have has some way to expose data, right? And now, so for example, it may be an API, it may be like maybe some text file that's being filled up with like logs, maybe something else that's going in, maybe it's S3 where like some data goes in. But all of these have like we assume that the tool has some way in which it exposes data, right? And then naturally, and this again, I'm sure that every single company that has built anything in the GenAI space that has integrations has at some point come and said, okay, let me build like a common adapter, right? And that adapter in theory at a very high level looks like what this image on the right, where you say that, oh, we have all these different formats. We'll have like this nice converter that like comes in, sits in the middle, converts it into a format on the right, right? But realistically speaking, if you ever have the unfortunate time to look into that universal converter box, you'll find that it is always going to be extremely hacky code, extremely things that are sloppily put together, lots of duct tape that's tying it together, kind of trying to make sure that this conversion between various data sources and something that your Gen AI application understands is like very, very patchy, right? And this is kind of where MCP came in, right? So with MCP, which is Model Context Protocol, basically the definition wise, what it says is an open protocol that standardizes how applications provide context to LLMs. And in a very simple way, what I would explain it would be like, especially since you're all DevOps engineers and SREs here, it is how OpenTelemetry defined the language for telemetry. MCP is looking to define the language for GenAI native services, right? So, and what that means is that there's a lot of service discovery happening. There's a lot of like tool discovery, the discovery of like the abilities of a service also happening. And MCP is providing all of this data in a format that is consumable directly by your generative AI service or LLM in general, right? Without, yeah, and there's obvious reasons for that. And I think the core reason for that is again, MCP comes built from Anthropic, who build really cool LLMs. So obviously it does make sense for them to like try to build a moat around having a protocol that kind of fits the way that their LLMs understand things, right? But the nice thing about MCP is that over time, more and more people started adopting it. Very recently, OpenAI also started adopting it. And just like OpenTelemetry, when it started off, it seemed like, oh, it's just a protocol. We don't really know whether it's going to pick up. More and more, we're seeing MCP kind of become the de facto standard in which we define services, in which services like present themselves to LLM applications, right? So now the obvious question is like, okay, you're talking about a service and you're talking about some application that consumes it, right? So isn't that middleware interface just an API? But the way that I would look at it is that an MCP server is actually more than an API, and that's why you'll very commonly see like APIs, like services that have an API also offering an MCP server, right? And think of it like it's more about service discovery. So if you had an API, for example, right, you have how would you like actually let an LLM know what that API can do? You'd probably have like something like an open API or a Swagger spec. You'd kind of send that to the LLM, tell it, okay, these are the APIs that I have, these are the data points that I have. Now, again, you need to like make sure that your open API Swagger spec is up to date. Make sure that the LLM kind of understands what are the edge cases that are there. Make sure that like your data formats, right? So for example, an API, you have like the get, put, post, patch, delete, right? But what exactly does the LLM return? Does it return strings? Does it return text? Does it return JSON? Does it return XML? Does it return text in some places, but JSON in some other formats? And we've all been there. Right? We've kind of built and worked with APIs like that. And automatically, when you have an API, if I am building an application to consume the API, there is no straightforward way for me to do that. Right? There's always some level of middleware that I need to write to like be able to communicate with that API in general. Right? And this is kind of why like MCP came and said, hey, like let's make it all simple. We'll have like one protocol that all services kind of have to agree upon, and if the service agrees upon the protocol, it means that any client that understands this protocol can talk to that service, right? And you'll see a few examples of this in just a few minutes. So broadly speaking, MCP is built up of a few building blocks. The primitives that they have are like called tools, prompts, resources, sampling, and routes. Primarily, I think that the tools is kind of the most interesting, and that's kind of what most people that use MCP are kind of building on. So tools, as it would suggest, is like the capabilities of a service, right? So for example, if we had Prometheus, right, maybe get metrics would be a tool. If you're talking about Grafana, get data source may be a tool. If you're talking about Stripe, right, maybe get like customers or get subscription is a tool. So all of these are like primitives that the tools are kind of the application abilities. Prompts are basically ways in which your MCP server can like give back prompting information to your LLM, right? So it's basically saying that these are the prompts that we use within our service that can be used to talk to our service, and so use these prompts. Right? Resources are again like information blocks. So for example, if you have like some context that you have within your organization or within your service that you want to like present to the LLM, then that would actually go as a resource. Sampling and routes are like relatively less used features of MCP in general. Routes kind of allows you to like define endpoints, and sampling allows you to like do completions on top of like SSL, right? Then finally, now again, here we're talking about the primitives of MCP, where we're talking about what an MCP server can do, right? But now, obviously, the next question is like, how can an MCP server actually be accessed, right? And for that, again, the MCP protocol does define two standard transports. So the first one, which you, and both of these actually are like gaining in popularity, but the first one is probably the way more popular, which is the standard input output, right? Which is STDIO in general. And the second thing is like server side events, or recently they've also done a streamable HTTP, right? Which for the purpose of this call, like we just refer to as SSC, right? And basically what this means is for the STDIO transport, what you're doing is you'll run like something locally within your machine, and then your LLM application or your MCP client is talking first to your local machine, which is then talking to some API endpoint or some third party service, right? So everything that you're running is running on your machine. And for server-side events, what you're basically doing is you're saying that I have some remote HTTP endpoint. So my local MCP client connects to that endpoint, right? And we'll see examples of both of these as well in just a minute. So now, how do I use MCP, right? Okay, so I have an MCP server. Now, what do I actually do with it, right? So the most common way of doing it is like most MCP clients would have like some sort of a configuration that looks very, very similar to this. And here we actually have an example of both an STDIO connection as well as an SSE, a remote SSE connection. And you can see the first one, which is server one that you see at the top, that basically runs server.py, right? It's some Python code that we're running, which has the MCP server. And then we have like our MCP client is able to like connect to this, right? Just connect to the server that is running within Python. And similarly, so you have server 3 that is there, where we have like we use this package called MCP remote, which allows you to connect to a remote SSE endpoint. And obviously, like because it's a remote endpoint, there should be like some capability for you to do authentication. So that authentication is actually taken care. You can pass different headers. You can do like OAuth-based authentication. There's a bunch of things that you can do on top. All right. So broadly, this is kind of how MCP kind of works. You create an MCP server, provide it with like tools, prompts, with the resources that it has, with the roots if you're interested, and like kind of you are able to advertise those capabilities to any MCP client, and any MCP client is then able to like access that server and like then use those tools, use those prompts, use those resources in order to build out GenAI applications, right? So it's been about like 12, 15 minutes that I've been talking about. I think yeah, so I can actually stop here and I'll hand it over to my teammate Nina, who's going to walk us through like some DevOps specific use cases where they're able to leverage MCP to do some really cool things, right? So over to you, Ninad.
Yeah. Thank you, Naveen. Let me just quickly share my screen. Yeah. I hope my screen is visible. Yeah. So, hey everyone, I'm Ninad, and I'll be walking you through the demos where we'll be utilizing different MCP servers to tackle specific use cases. We'll start by seeing how MCP can simplify fairly complex workflows with actual working examples. So the environment setup that I have here is basically I'll be using a MCP client. It can be a Casa ID or a cloud code or a cloud desktop, anything that supports the MCP protocol. And in this client, I'll basically integrate MCP servers, different MCP servers, which in turn again support the MCP protocol, hence the name MCP servers. Yeah, so I have actually went ahead and integrated a few MCP servers into my cursor ID, which I'll be using as the MCP client. And as you can see, we do also have a JSON that the Naveen just showed, which also kind of provides the a way to integrate our servers. But cursor also allows a UI where we can integrate the servers. Yeah, so moving to the first use case, I have a Python script, a simple Python script, which basically prints the current date and time. So imagine you have a similar kind of script, right, where which can check an API, logs, even metrics, or just perform some routine cleanup. Now, typically, to get the script running on a schedule in your Kubernetes cluster, you will probably need to build an image first, push it to your Docker Hub, and then write a YAML manifest for the cron job resource, and then apply that YAML manifest in your cluster to get the cron job deployed. Let's check how we can perform the same set of tasks using MCP servers. So the servers that I'll be using here will be a Docker MCP server and the Kubernetes MCP server. So I'll quickly go ahead and activate those servers. And yeah, so here we can start prompting, and I have the prompts ready. So we can just go ahead and input those prompts. So here I say that I want to build an image of the attached Python script. I have given the script as the context here, as you can see. And we also have a Docker file, which can be utilized to build the image out of the script. And I want to deploy this cron job, deploy it as a cron job in my clusters. I have provided some details such that I want the image to be supported by the Linux AMD 64 platforms. And I want the image to be pushed on my Docker Hub, where my username is I have provided my username, and then I have also provided the namespace where the cron job should be deployed. So as you can see, it has started acting up, and here you can see everything that the copilots do when utilizing MCP servers. We kind of need to give permission, so we have a fair bit of control on what the copilot does. Right now, I can see that it is trying to build the image and then push it to my Docker. Yeah, so I'll just say run. It starts acting. In the meanwhile, I can show you my cluster, and you can see here I'll get all the resources that are present in the MCP demo namespace, and we can see that currently there are no resources, nothing is present in this namespace. Now we would like to deploy the cron job, and looks like the copilot has used the server to push the image. Now it is trying to invoke a create cron job function. This tool is basically present in the Kubernetes MCP server, and it is trying to utilize the tool. It says it inputs a bit of parameters where it inputs the name, the namespace where it wants to deploy, and the schedule for the cron job. I have mentioned that I want this cron job to be run every minute, so we can see the logs through the job. Yeah, so I'll just go ahead and say run tool. Yeah. It says that it has deployed the cron job. We can actually go ahead and verify. We are connected to the cluster, so I would just say get the cron job, and you can see there's a new cron job that has been deployed in our cluster, and it is deployed just 13 seconds ago. That means the copilot has deployed this, and then we can get the pods. So we'll have to wait a minute, since the cron job runs every minute. The pod will come up in a minute, and we can verify the logs by the time. Yeah, so you can see how fairly simple it is to basically uh, deploy this script using a cron job. So as I said, the traditional steps would be to run a lot of boilerplate, and there will be a lot of repetition involved. But with MCP, I can just write two or three lines of prompts and then get the same stuff done. Yeah. We can see that it has created a few pods, and if we check the logs of those pods, yeah, it does say the current time and date, which is what the script was meant to do. Yeah. So this was the first use case. One thing you have noticed that we did not write any YAML manifest for the cron job. The copilot was able to figure it out, even apply the YAML manifest and deploy the cron job into our cluster. Yeah. Now that we have seen how easily we can deploy a script using MCP, let's move on to see where how we can make use of servers like Grafana and Atlassian. I'll quickly start a new thread, and I'll pass the MCP JSON as the context here. I'll go ahead in the MCP settings, server settings, and I'll enable the Grafana and MCP Atlassian servers. So the Grafana MCP server and the Atlassian server. The Atlassian server does have Confluence and Jira integration, so we'll be utilizing the Jira integration. So let's talk about a common operational behavior. Let's say you have an observability stack like Grafana, which fires an alert, right? It can be a CPU spiking, a service is down, and you would like to create a Jira ticket for that event so you can track the issue, right? With MCP, we can check for incidents like this and create a Jira associated with it to track the event. So I'll be using the Grafana server to basically fetch all the firing alerts that are currently present in my Grafana. And then I'll use the Atlassian MCP server to basically create the Jira for it. Yeah, so let's input the prompts. Yeah. I have prompted here to fetch all the alerts present in my Grafana. I have also provided a minute detail that I have more than 100 alerts, and I want to find out the list of firing alerts. It has already invoked a tool, and due to the detail that I provided, the input parameters of the tool usage change. That is why it is sometimes necessary to provide small details that can be utilized by the copilot. Yeah, we can see it has come up with the result, and it says that there are these three firing alerts present in our Grafana. Now I would like the Copilot to create a Jira associated with it. Again, I'll here provide a little more details, such that I want this ticket to be assigned to Naveen, and I want this ticket to be created in the demo project. So to show the demo Jira board. Yeah, currently we have nothing in this board. uh, Let the let the tool here create the issue, and we'll check the board once again if that is being reflected in it. Yeah, yeah, it has ran the tool successfully, and let's check our Jira board now. Yeah, here we can see a new ticket has been added to the demo board, and it has kind of fairly described the issue, and it has also assigned it to Naveen Pai. Yeah, so whatever we were intending to do, that has been done by the Copilot. Yeah, so moving on. We'll be using the GitHub and the Argo CD MCP servers to tackle the third use case. We'll check how they can be used to make customer specific deployments for us. Yeah. So let me start a new thread again and pass the context as the JSON. We'll deactivate the servers and activate GitHub and Argo CD MCP servers. Yeah. So in most real world platforms, different customers often run isolated deployments, right? Each can have their own versions, services, environments, and infrastructure. In this case, we are basically looking at a customer specific deployment for Aiden. And I have created a demo customer named Acme, in which I would like to update the Aiden image deployment tag, right? I would like the Aiden to be using the latest version. So let's see how we can utilize these two servers to achieve that. Yeah. First, I would like to basically check the image that is currently that is currently present in the Acme Aiden deployment. So we have these Helm chart deployment present at this path in one of our GitHub repos, and I have basically asked it to check the image tag of the Aiden server that is present in the deployment. Yeah, it tries to fetch the get files content via the get files tool, and yeah, let's see what it comes back with. Yeah, it has come back. I think first it tried to access my workspace, which is the Copilot workspace, but it does not find the necessary file over there. So it went to the GitHub and basically fetched the image tag for the Aiden deployment, and we can see the tag is this. Now I would like to update this tag to the latest image tag. I already have the latest image tag for Aiden, and I would ask the Copilot to raise a PR for it. Yeah. First, it is trying again to get the file contents. We'll approve that. Yeah. It is trying to create a branch. We have not provided any branch as of now, so it is trying to use its own branch. Let's wait for a minute for the tool to be executed. Yeah, here we can see it is calling create or update file. Let's run this tool and check what it does next. Yeah. We see a create pull request has been called. A tool has been called. We'll allow it to create the pull request again. Yeah, it says the values file has been updated with the image tag this that we provided, and it also has given me the PR link. I'll just go ahead and open the PR link and show you guys the PR that it has created. Yeah, so it says update Aiden server image to this. Let's check the file contents that it has changed. And you can see I wanted to change the image of the Aiden deployment. And the previous version was this. And I have the updated version right here. So I'll just go ahead and merge this PR. Yeah, now that we have merged the PR, I would like to access my Argo CD and check the application status from there. So I have prompted it that I have merged the PR and I wanted to connect to the to my Argo CD and check the Acme Eden application and sync. I have also asked it to sync the application and get the sync status. So from the Argo CD MCP server, there's a tool called list applications. It is trying to run that, and the project name is Acme. So yeah, this is the tool output. It should try to come with the application name. Yeah, so it has figured out the application name on its own. The Acme outsource Aiden is the application name, and the it has called the sync application tool. We should basically sync the newer deployment that we just made. Yeah, and it is trying to get the application details now. Let's approve that as well. Yeah, it says your Argo CD application has been synced. The application is successfully synced to the latest version, and the pods and all seem to be in healthy state. Yeah, so I was basically able to update the image, create a PR for it, check the status for the deployment via Argo CD, all while I was sitting in the MCP client itself. I did not have to, just apart from reviewing the PR and then merging it, I did not have to leave my ID anywhere. Yeah, so to sum up my demo, an observation here to make would be, noticed how we were able to do this repetitive redundant task just by writing 2 or 3 simple prompts, rather say vibe coding. Like, were we able to perform tasks like these using copilots before? I don't think so. And well, it's all possible now, all thanks to MCP. This is the protocol that will be known for turning copilots from passive assistants to active collaborators, and while we are controlling them from the backseat. Yeah, I'll hand it back to Naveen now to take us deeper into what's coming next with MCP and how we ourselves have integrated MCP with Aiden. Yeah, over to you, Naveen.
Perfect. Nana, you successfully managed to like piss off half of our audience by using the word vibe coding, while the other half are like big fans of your work. So it's really cool to see like how much you're able to do now with GenAI purely just through a conversational manner, right? Things that were unimaginable for some of us who have been around like slightly longer in the tech industry. These are like very, very like yeah, the shattering moments, right? In general. But now that obviously when it comes to Aiden, right, which is our DevOps copilot, and we've been playing around, like I mentioned at the start, with MCP for quite some time. We did start off obviously building out our own integration framework for our agents that we had, and then over time, yeah, we were like kind of built out something that works for the use cases that we have. But obviously, with the whole hype around MCP, we did explore MCP quite deeply, and we've been like part of lots of discussions, whether it's about what the protocol itself should be, whether like making contributions to some open source MCP servers that are there, figuring out things like authentication, figuring out security, which are like some of the things that I think have been built, are imbibed into how we do things at OpSource. But kind of as MCP is developing as a protocol, it kind of puts us in the right place to be able to have opinions on that, right? So with that, without further ado, like I have a few announcements that I'd make with Aiden, right? So the first things, as you would have expected from a call, from a webinar about MCP, we do also have the Aiden MCP server that is now live. If you are an Aiden customer, you just need to like create an API key that you can do from the settings page on Aiden, and then just use https aidenmcp.opsource.io/sse as a remote MCP server. And what this allows you to do is very quickly bring Aiden's capabilities into any application that supports MCP. So, for example, what Ninad showed with Cursor, right now, Cursor also has MCP, has Aiden capabilities. And that basically means that you can use Aiden's capabilities to like make changes to code. You'll be able to use Aiden to like actually get information about your running services, about your observability tools that Aiden is integrated into, about your CI/CD tools that Aiden is integrated, about AWS, about GCP, about whatever cloud you're running on, about your databases, right? All that information is available to you wherever you're working, right? Irrespective of whether you're working within Cursor, Windsurf, Plot Desktop, wherever you're working, the Aiden's capabilities kind of are now available at your fingertips, right? And just to do a very quick demo, I'll show a very quick example that I have here. So yeah, this is Claude Desktop. Claude, as you would expect, does not know anything about Aiden or about OpSource or anything that we do, right? But I have like one quick question here that I'm gonna ask. Let me just ask Aiden. Uh, latest. So yeah, all that I'm doing is I'm just asking Claude Desktop to ask Aiden to get the latest version of all running OpSource services. Like Ninad showed at the start here, there's an approval that is required. So it says we have this integration called Aiden to the Aiden MCP server, and it wants to use a tool called Ask Aiden. So let me just allow it for this once. And behind the scenes, what's happening here is like we have an authenticated workflow where this query that I'm asking is going to Aiden, which like is authenticating with the user, making sure that we then go into the user's context. In this case, the user's OpSource itself, and it's kind of going to like fetch that information, bring that information out, which is then going to be like sent out to the LLM, which is then going to summarize this information for me. Right? So we'll actually see like this kind of use case that kind of becomes very, very interesting more and more as we grow with MCP kind of use cases, right? Where irrespective of what data source you have, where you're working is going to be where your information is, right? So yeah, we're seeing like actually data start to come in now. So yeah, you'll see like Aiden UI console UI start run Aiden MCP, right? Yeah. So all the data, including the Aiden MCP itself, the current running version that you have. And then it says like, oh, do you want any more information, right? And again, just to stress on that, at no point does Claude know about OpSource, about Aiden. It doesn't know anything about what services we have. We have not given any of that. We have not had to integrate anything. All that we've done is we've like integrated like one MCP server within this and kind of being used to able to use that tool that the MCP server provides to get these answers for us, right? Along with that, again, we wanted to like expand what Aiden can do as well. And since now we have like we're seeing like more and more services actually end up building out their own MCP servers, like we also have. We went one step further and we also have like the Aiden MCP integration, right? Which is basically it means that any MCP server can now act as a data source for Aiden, right? Or for a tool source for Aiden. And again, for any OpSource Aiden customer, you can just go to aiden.opsource.io/integrations ID equals MCP to configure this. Today, because of the way that MCP works, we can only integrate with any remote MCP server. So any remote MCP server that you have, we take care of auto discovery of tools, and very soon we'll also do auto discovery of prompts. And today we do support header-based authentication, and auth-based authentication is something that's coming soon, right? So that basically means that you'll be able to like, irrespective of what your tool is, irrespective of whether OpSource supports it or not, you will actually be able to like, if there's an MCP server, you'll be able to use it within Aiden, right? And if you think about it, it's kind of a circular workflow where because Aiden also provides its own MCP server, it means you can actually use any MCP server wherever you want to use it through Aiden as well. So you can leverage Aiden to make your MCP server smarter because of the way that Aiden is built. So very quickly, I'll like show a quick demo of this. So if you go into our integrations, so we have like a bunch of integrations, and now something that's come in very recently is the model context protocol. When you click on manage, it's again just about you giving like a URL, your authorization. I've created one header, one sample here, one sample MCP server here. So as you can see, it's a Pinecone endpoint. Pinecone, for people who are not aware, is a vector database. So if you notice, yeah, OpSource does not actually have, Aiden does not have a like a ready-made integration with Pinecone, right? But because Pinecone supports an MCP server, we basically can give the URL, we give like some authorization headers that you have, we give like a server name and a description, right? And here we're just saying that, oh, these are my release notes and these are the where we maintain our release notes. Right? And what I can then do is like just with that setup that I have of like easily going to a UI and like putting in 3 details, I'm actually able to go and ask, uh, can you get me my let me just say get me my release notes for April 2025, right? And what this is going to do behind the scenes is going to use the MCP protocol. We have an agent for MCP now, so that agent kind of uses the MCP protocol, identifies the tools that are available with that MCP server. That becomes part of like the rest of the agents that we have as part of Aiden. And basically what it does is it goes to the MCP server, gets the tools, identifies the query that the user is asking, what is the right tool to use for that, and then decides, oh, based on this, what I need to do. Can I use these tools? Uses those tools, get that information, pass it to Aiden. Aiden does its thing on like in terms of like figuring out what needs to be summarized, what needs to be brought into focus, and then kind of building on top of it, right? And you see like this actually shows the release notes that we have for April, which has a bunch of things that we did this April, right? And this is actually pretty much true for what we did this April. So most of these things that you see, the Aiden MCP server, Aiden API keys, MCP client support, remote runners, deeper Aiden Observe Now integration, and the GitHub integration we do. Right? So these are some things that came up. And again, you notice that all that I did, at no point, I do not know how Pinecone works. I do not know what the query format is. Does it use SQL? Does it not use SQL? Does it use some NoSQL format? At no point I had to connect to Pinecone. I've just used the MCP server, integrated into Aiden, and Aiden is able to build on top of this. Right? Because of the way that we have built out Aiden, again, as an MCP server as well as a client, it means that this information that you have from Pinecone can also be brought into your Cursor or your Windsurf or your Cloud Desktop or any other MCP client that you have along with Aiden. Right? So again, like I said right at the start, the way we look at Aiden is as a senior DevOps engineer who's just joined your team, right? And you just point him or her towards what you want to get done, and Aiden figures out the rest. Right? It's completely just conversationally driven. You don't have to tell him or her, oh, this uses SQL, this uses that. And one thing that I'll quickly add upon, which is like slightly different than what how Ninad did his demo, right? When we did the demo, you might have noticed with MCP in specific, we have to give a lot of details, right? We have to say, oh, this is where our code is, this is the file path you need to use, this is where like stuff needs to get done, so on and so forth. But with Aiden, because Aiden kind of builds out its own knowledge base, we can actually just give questions like, can you get me my release notes? Right? You don't need to say, my release notes are in Pinecone, use the Pinecone MCP server. Oh, it's in this assistant called XYZ. It's in a file called so and so. You don't have to give all those details. MCP also by itself is able to do some of these things, but it's like a lot more flaky than Aiden because it's like a purpose-built agentic system that we have for DevOps workflows. Right? So with that, yeah, like I think we had these two announcements for Aiden. Aiden now is both an as a MCP client as well as an MCP server, and we're very excited to see like what are the kind of things that people want to use Aiden for now. Now that we have MCP clients, one use case that's become very interesting for us has been people who, especially larger enterprises, right? They have a lot of inbuilt tooling that they had, and always the thing has been, okay, you guys support like tool A, B, C, D, E, but we have something that we have built internally. Right? So how can we actually bring that information as a data source for Aiden, right? Or as a tool source for Aiden? And so far, we've always been talking about like building out custom integrations for different customers, right? But with MCP, what that allows us to do is just say, okay, if you have an MCP server that you have accessible for that, Aiden can integrate with that. You don't have to go through the effort of trying to have to build something custom, build a custom agent all over again. You can just leverage this beautiful protocol called MCP and kind of build on top of that, right? And allow that smarts to be brought into Aiden. But obviously now the question is like, if I've spoken so far, like me and Anand have kind of hopefully piqued your interest around things that MCP can do. But there are obviously a few challenges, right? And that's kind of what we focus on for the last few minutes of our webinar. So primarily the challenges that we have, right, is one, which is the most common thing. MCP makes really good demos, and if you have been on like X or Twitter or LinkedIn or any of these other social networking sites, right, you'll see a lot of beautiful demos with MCP. But when it hits production, MCP by itself is not particularly great at handling complexity, right? And the more complex things get, the more harder it get. And one thing I'd point out is that you might have noticed when Ninad did his demo, he actually turned on two MCP servers, turned off a couple, then again turned on a few, turned off a couple. And the reason for that is like the more tools that are available and the more servers that you integrate, like LLMs in general find it hard to pick tools, right? And Anthropic is called out like a soft limit of about 40 tools. But with a system like Aiden, we've actually built out that complexity handling part has been like a primary focus, right? So that's something that like MCP by itself doesn't do really well today. Secondly, like lack of auto discovery, right? And that basically means that when you have an MCP server, you're able to discover what capabilities it has, right? But how do I find out whether a tool that I'm using has an MCP server or not, right? Does Grafana have an MCP server? Is it something officially supported by Grafana? Is it something that's like actually supported? What are the capabilities that a Grafana MCP server has? Right? Are there new capabilities that are coming in? Are there like different MCP servers provided by different people for the same tool, right? How do I discover these servers? That's obviously an open problem for MCP servers. Anthropic in general is trying to like solve this by creating an MCP registry, but like more often than not, I think like there are other third-party services that are playing that role of MCP aggregators. But there's still like no one clear way of like being able to say that okay, these are the capabilities that we have with an MCP, these are the servers that exist. The third thing, which again is something that I mentioned about a minute back, is lack of intrinsic context. Right? So MCP is a very nice protocol when you're talking about this is my LLM and these are my tools and how does a communication happen between them, right? But MCP by itself doesn't particularly do a great job of maintaining context. And as you know, like I think context is kind of the difference maker between what is like a nice demo versus something that's a functional application or something that actually scales with time. Right? And that context is something that most organizations build out outside of MCP. People are trying to like build something within the protocol itself to handle context, but yeah, so far like that's been a challenge in general. Right? The fourth thing is like server-side scaling, which is again the way that MCP has been built from day one. Either expects you to like run something on your local system, which again is not something that you'd expect too many people to be doing all the time. And at the same time, if you try to host a remote MCP server, then it uses like it's a stateful server, right, for all practical purposes. So server-side scaling has been like something that's very hard. I think like 20 years of like us being able to go to from stateful servers to statelessness has kind of been undone by MCP starting choosing to like use a stateful server. But again, there's like work that's being done on that to allow like stateless servers. That's something that's like also being worked on actively. And finally, this is like an interesting thing that most open standards have. So you have like an evolving standard, right? And we've kind of been at the brunt of this where we've seen like breaking changes come into MCP, into the protocol itself, that have kind of had to make us go back to the drawing board and rework some things. But I think along with the fact that MCP is an evolving standard, it's also the fact that there are other standards that are also being proposed, right? And some of these are backed by equally large organizations. So, for example, there's a protocol called A2A, which is agent to agent, which is proposed by Google. There's a protocol called ANA, which is again another protocol that is there for like agent to agent communication. Right? So now again the question becomes similar to how OpenTelemetry was maybe like 4 or 5 years back. Right? Will MCP actually be the protocol that grows over time? Is an open question, and we can only answer that. Two other things that MCP is trying to do. One is they're trying to build out agent graphs that kind of allows agents to understand each other a little bit better and the capabilities a little bit better. So that kind of allows like that handoff to happen between, hey, like I did this, now you do this. Now you did this, now I expect this from you, right? Kind of those communications to happen a little bit easier and kind of be able to build agent graphs. And the obvious last thing that we have is like multimodality. So for all practical purposes today, MCP is a text-based service, right, or a text-based protocol. So everything that it does is primarily set up towards like having text conversations where, because at the end of the day, it's trying to just give data to an LLM. So again, something that MCP is developing into is to support multimodality, and that again is something that's like very interesting, right? So while MCP is like very very interesting as a protocol, and I think the fact that it's becoming adopted more and more is super super interesting. At the same time, it's not to say that it is perfect in any manner. So if you like start building for MCP, and especially if you're in the DevOps space or in the coding space where the difference between like something that works really well and something that's absolutely useless maybe very very small, maybe a 5% 10% is kind of the difference between something that's great versus something that doesn't work. Then yeah, these challenges are something that definitely I would say that you should like explore a little bit more and figure out how to manage on your side, right? So with that, yeah, like I actually come to the end of what I had to talk about. I'm hoping that like this was helpful for everyone to get an overview of like what MCP is, how MCP can be used with DevOps, how DevOps engineers can also vibe code a little, right? I think it's like very critical for DevOps engineers and SREs to also understand that generative AI tools are at this place where we can actually bring a lot of value to our workflows, especially for the more like painful workflows that we have, right? The more repetitive workflows that we have. And the nice thing, like GenAI kind of lends itself very perfectly to these kind of workflows. So definitely, I'd say like do play around with MCP. People who are interested do sign up for Aiden, play around with Aiden. Aiden kind of, like I said, kind of offers you the best of both worlds as an MCP server as well as a client. And that means that you can kind of play around with MCP as a protocol as well as understand how to use a DevOps specific copilot for most of your workflows. And I hope this was useful for everyone. So thanks so much, guys. So with that, I'll hand it over to Tero. I think we have a few questions, so I can take those up. Okay, yeah, I can actually start off with these questions. The first question that I have here is, please answer the security aspect. The credentials you're configured, are they safe? So the answer is yes, they are safe. Like I said, it's something that is very critical for MCP in general has been how exactly do you have access to like services that are completely remote, right? So again, most of the methods that you would use for accessing an API, right, whether it's an API key, whether it's an API token, whether it's like some sort of OAuth based workflows, we're creating an access token and a refresh token. you can actually do all of these things within MCP. Right? MCP does. They don't particularly have strong opinions on how you should do that, but I think more and more we are getting to that point where that is something that is going to be answered. Right? Yeah, we have a few questions about whether the video is going to be available for watching later. Yeah, I think like it will be available on LinkedIn Live. And then we have one question about, can MCP server work in an air-gapped environment, right? And yes, an MCP server can work in an air-gapped environment, but the only condition there is that whatever you are trying to access with MCP should also be within the air-gapped environment, and your LLM should also be accessible within the air-gapped environment, right? Because at the end of the day, like I said at the start, MCP is all about giving data that you have from some tool to an LLM. So as long as you have a self-hosted LLM, say if you're using Olama or using something like that, and you're then trying to get your tool to collect data from some tool, send it to Olama or like something within your air gap itself, get the data back, and your client is within the air gap, your server is within the air gap, and your LLM is within the air gap. As long as everything is kind of air gap, then yeah, it works perfectly fine. Yeah, we have another question which is like, which AI is behind the MCP server? I'm not particularly sure about the question, but in general, yeah, like the company that brought out MCP is Anthropic. So they built Claude. Right? Claude is the most famous set of LLMs that they had. But again, like I think OpenAI also supports MCP right now. Most of the common players are moving towards it supporting MCP because it's become popular enough that it kind of becomes a business use case also to allow to support MCP, right? So again, there's no real, even though Claude or the Anthropic guys are the people who created MCP or they launched or they have put their backing behind MCP, you can still use MCP with other LLMs as well. Right? There's no specific reasoning for you to only use Claude or only use the Anthropic models. Cool. I'll maybe give another 30 seconds if there are any other questions. Okay, I have one question here, which is, what is the easiest way to host a remote MCP server? Two, three ways actually that you can host a remote MCP server. So assuming that you have, if you have a fast API, a Python endpoint, then there's a service called fast MCP that you can literally like, it's just a Python library that allows you to like take any fast API endpoint and like convert it into an MCP server that can then be hosted anywhere you want it, anywhere you host your APIs. Similarly, Cloudflare actually is also like put in their might behind MCP. So Cloudflare, if you see, they have like a ready to run. They use Wrangler and they are a library called Wrangler, and like they're able to like create MCPs that can also handle OAuth. Right, that's something special about like Cloudflare is they kind of handle OAuth for you, so you can do authenticated MCP servers without having to write too much code. Right, so that is like another straightforward way to like handle and host remote MCP servers. Right? And I think more and more as we are seeing organizations are kind of making that movement from like STDIO based MCP servers to like hosted MCP servers because it kind of gives more control in general around like adding more capabilities, updating, making changes to endpoints, kind of everything. Right? It kind of becomes a managed solution. So that's why yeah, we're seeing like more and more remote servers kind of become the norm. Okay. Yeah, we have like one final question. I think I can take that. That says that currently there's no built-in support for MCP server access in agentic platform like Bedrock and Foundry. Is it a good idea to call MCP server using MCP client using return of control? Absolutely right, and I think that is kind of very similar to how we do it at Opsuous as well. So the basic protocol that we have is like you need to the thing that I'd stress upon is like MCP does not in any way replace agents, right, or does not replace any sort of agentic workflow that you have. What MCP is doing is it's providing you one protocol in which you're able to communicate with an external third-party tool, right? Now, obviously, that means that it does not in and of itself replace an agentic flow, but it's providing you like additional access. So there are like lots of ways in which you can do that. Return of control is like one way that you can do that, where you're basically telling the MCP server, you're telling the MCP kind of get this detail and then tell me whatever you get, right? So and then kind of building on top of that. There are different models that are there at play, but yeah, I don't think there is too much literature on what is the best way to do it today. But yeah, I think return of control is like arguably probably the most popular method to kind of build that out, build out use cases like that. Cool. I think with that we should be good. Once again, I'd like to thank everyone for like taking your time out. I know, like, yeah, I was just looking at the file while Nina was present, looking at the visitors, and we do have like visitors from quite a lot of time zones. So yeah, thanks again for taking time out. People who are joining us early in the morning, in the afternoon, and people at night, right? Who have done this at time of dinner. So thanks so much, everyone. I hope this was useful. And thanks, everyone. Have a good day, have a good night, and we'll see you again on the next webinar. Thanks, guys.
Thanks, guys.